All right, so let's keep going here and start to take a look at example number 2. Can I determine with justification whether this series converges or diverges? Again, since I see a factorial here, it doesn't mean that the ratio test is the way to proceed, but it might mean that at least out of all of the options that I have, maybe the ratio test seems like an ideal way to at least attempt. I could probably see that maybe doing something like an integral test would be silly because, well, I don't really know how to integrate when I convert over to a matching functions if there's a factorial. So maybe we'll start with the ratio test and see how far we can get. I would ask you to pause the video here and see if you could start by checking the conditions and setting up that ratio test limit if you're allowed. And don't be too surprised if when you get into that limit calculation that it gets a little bit more complicated than maybe you'd expect. Do your best to try to work through it, and then when you unpause the video, you can see me kind of work through the solution. But give yourself at least the opportunity to tinker around with this. Okay, so here's what I would actually go ahead and do. I would see this. I would start off by saying, clearly, the series contains only non-zero terms, right? There's no way I'm getting zeros out of this. So I'll go ahead and start to calculate that big limit. Now this can get a little bit frustrating here because it's a big, nasty looking limit that we're going to come up with. But I just have to move through it slowly. Again, I have absolute value bars. I can't ignore those. I'm going to have in the numerator here, I got to replace all of my k's, all of them, with k plus 1s. So notice how messy that numerator now looks. The denominator, though, is still pretty tame. That's not too bad. If I was to then go ahead and start to think about the absolute value bar simplification, I might recognize right away that, well, all these things, again, only really make positive numbers. So there's no reason to really have the absolute value bars there. So I'll even go ahead, remove the absolute value bars, and I'll go ahead and multiply by the reciprocal in the same step. So I get something that looks like this. Now, there's not much I can maybe do with this, at least at first glance, and maybe this is where you started to get a little bit stuck. Notice you could simplify out the factorials a little bit, and I'll start with that. The rest of the stuff here seems a bit difficult. Notice that I could be left with a k plus 1 to the k plus 1 on the numerator. In the denominator, I get a k plus 1 left over when I simplify down these radicals, and then I still have a k to the k. This is a nightmare to try to take a limit of, and so I can actually continue to look for ways that I can simplify. Ooh, and one thing you might notice is that you have a certain number of k plus 1s in the numerator. You have k plus 1 of them. And in the denominator, you have 1 of them. So in total, when you think about simplifying this down, I should end up with k plus 1 to the kth power, because I have to remove 1 from it to cancel out with the bottom, over k to the power of k. Now this is still really ugly, but with the following simplifications, we can arrive at an important idea that probably was discussed in your Calc 1 class. Notice here, I can rewrite this as everything to the kth power, and then I could even separate it to actually look like 1 plus 1 over k to the power of k. Notice all I did here is I just split the fraction, k over k and 1 over k. But here's the surprising thing. I think that in Calc 1, you talked about exactly what this was equal to. This part here is from Calc 1. That's actually a very powerful and special limit. It's a very convenient one to remember from time to time. Now, you may not remember it here, but in case you don't remember it, let me just quickly remind you that that is the definition of the number e. E is the answer to that limit. Okay, so that's a whole lot of work. I might not remember that fact, but if you don't remember that, I would highly advise trying to dedicate that to memory because it's a very, very crucial piece of information here. Now, of course, I can recognize then that I found that rho was equivalent to e. Since e is bigger than 1, I know what I should conclude. If I go back up and I look at the ratio test, it says if you get something bigger than 1 for rho, the series just regular old diverges. So I'll say, so by the ratio test, the series diverges. There we go, argument complete. Okay. All right, we'll pause this video here and then we'll pick up in the next video on example number 3.